Okay, let's try to do questions for each of these things, uh, the methods for doing each of them without spending too much time. So the first one, when you see a different time, you have to do up two different equations, and we have to always work with v is equal to distance over time, or speed is equal to distance divided by time. And you have to learn that triangle, or you can just learn how to algebraically manipulate letters. Since we have two different times, we want it to be t is equal to something. So you cannot have it on the denominator. So we're going to multiply both sides by t, or you can use the triangle. When I do this, the t's cancel. And now I want t all alone on the left side, so I'm going to divide by v on both sides, and the v's cancel. So you get t is equal to distance over velocity. Since her time is different when she goes with the wind and against the wind, we have to come up with two different equations, and we always have to have a fraction form because this whole section is about fractions. So we need to know what her distance is, right? Because we have t going with the wind is equal to this distance. Well, the distance in this question is always 6. It's always 6. So we're going to come up with two equations. One when she's going with the wind, and when she's going against the wind. Well, what's her speed when she's going with the wind? It's her speed, whatever her speed is, plus the wind speed. That's an equation we did before. We just kept it on the numerator before. And what's her speed when she's going against the wind? Well, it's her fighting the wind. So it's Emma minus W. That's the trick you have to remember over and over again about the velocity in these things. So we get two equations. You might think we could just, oh yeah, now the time. Well, going with the wind, she's 1 hour. Going with the wind, she's 1 hour. So big old 1 here. And going against the wind, it should take longer, right? Because the wind's pushing against you. It's taking 2 hours. Now, conceivably, you could add these two equations as I've done here to equal the total time is equal to 3, but you discover that it does not work at all. You get a 3e squared minus w minus 3w squared is equal to 0. There's no possible solution except for 0. So you have to do the equations and solve them individually, and you have to come up with a equation for E that can fit in the other equation, because here we have two separate equations with two missing information. When you have two equations with two missing informations, you can solve it. If it was three missing informations, you'd have to have three equations. Our first step here, remember these are fractions. You've always got to come up with a formula like that's its fraction, because this whole section is about fractions. So let's solve this first one. We don't want a denominator like that. So whenever it's added, two things are added like this in the denominator, put brackets around it. That will remind you to just multiply the whole thing to get rid of the denominator, but anything I do to the right side, I have to do the left. Anytime you have a fraction, you multiply by the entire denominator. The entire denominator divides itself and becomes 1, or as is common to say, cancels. Over here, we have a distribution. It's got to be 1 times each of these things. That's why we put in the bracket to remind us that we have to multiply 1 times each of things. But fortunately, 1 times each of these things is just each of these things. So we can just ignore the 1. So we get a very simple equation. That's equation 1. The second equation, when she's going against the wind, you've got to do the same thing. You've got to treat your denominator if it's married. And you have to get rid of it as a team because they're being added, not multiplied. If they were being multiplied, you could do it individually. So to get rid of it, I multiply by the whole thing, but anything I do to the right, I got to do to the left. It, of course, cancels again. And we can see a slightly more difficult formula because this 2 has to FOIL against each of these things. 2 times E, Emma's speed, is this, 2E. And 2 times the negative wind speed is 2W. So you get a slightly more complicated equation because it's got a 2 multiplying these things. So clearly this one on the right is easier to manipulate in terms of getting either W is equal to something or E is equal to something. It doesn't matter what you do. You can say, well, E is equal to 6 minus W. Or you can say W is equal to 6 minus E. Either one will work and substitute into the other equation. But let's figure out, let's do for Emma and do 6 minus W and put it in brackets because there's a minus there. So now that I have a formula for E, and this is the secret to solving all two missing equations, is you are allowed to substitute anything that is equal to something for something else. So I'm going to just move this a bit to the right, and move this to a bit to the right, and you see this E here. Well, since this E is equal to this, I can just replace the E with that. But again, I have a FOIL situation. It's got to be 2 times the 6 and 2 times the minus W. So I got 2 times the 6 is 12. 2 times the minus W is minus 2W. I got another minus 2W, and is equal to 6. Now, here's where a lot of students make a mistake. They think this cancels out, but it's two negatives. It's like adding them. What's 2 plus 2? It's 4, but it's in negative land. So it's negative 4W. Now I want the negative 4 all alone, so I'm going to subtract 12 from both sides, because that's a positive 12, and everything's being added and subtracting. So I got to add and subtract. It cancels the left side. That's why I did it. Or actually, it turns to 0, different than cancels. And 6 minus 12 is minus 6. Then, to get rid of this minus 4, I'm multiplying the W because I want to solve what W is. I divide both sides by minus 4. On the left side, I have this. And on the right side, I have minus 3. Well, minus 6 over 2 simplifies to minus 3 over minus 2. The minuses cancel. Whenever you see two minuses, just work with positives. And this is 3 over 2 or 1.5. Now, sometimes, and since we're working in kilometers and hours, and we were finding her speed, that's the wind speed. Now that you have what W is equal to, you can go back to your very simple equation that you had here. E is equal to 6 minus W. And since we have an equivalent to what W is equal to right over here, we can replace W with this. And really, it's 6 kilometers. Yeah, it doesn't matter. It doesn't matter that it's 6 kilometers. And then you get 4.5. So we've just, and remember, it's a speed, kilometers per hour. So we've discovered Emma's speed and the wind speed. All of these equations where the time is different are going to be like that, okay? So now I'm going to race through them. We can see that, so we're going to call him a canoeist. And we're going to call the stream water. So it takes him with the water, it's only going to take him 1.5 hours. And against the water, it obviously is going to always take him longer, 3 hours. So that was that's time. So we have to figure out a time formula. Same as last time. Time is equal, since velocity is equal to distance over time, time is equal to distance over velocity. The distance is consistent each time. So we do one equation. Time is equal to distance over velocity for when he goes downstream. And then we just fill it in. And time is equal to distance over velocity when he goes upstream. And we just fill it in. Now, fortunately, each time the distance is the same. 12. Just do it like this instead. 12. And so the distance is 12 here and 12 there. The velocity formula we've come up with right here. This is the velocity going with the it should be equal to that. That was just, sorry. This is what it should be, just a formula for velocity. And against the wind, this is the formula for velocity, because he's fighting the wind's velocity. Any velocity along a single direction, when you're going with something, you add them, and when you're going against something, you subtract them. Well, we obviously don't know it, but we do know the time. We know that the time for one direction is 1.5 hours. And that's important to put the time with the right one, because the 1.5 hours is the shorter time, so it goes with the C plus W. And the other time in the other direction was 3 hours, so we put a 3 with this one. Very important. And then it's the same thing as last time. We're trying to get rid of the denominator, so you always put a bracket around it. And you solve individually. Okay? So on this right side, this is a little bit harder. Why? Because we're no longer working with 1. We have to get rid of the C plus W. I'm going to multiply both sides. And obviously they cancel on the right. And on the left, we have a different distribution, right? It's 1.5 times the bracket instead of 1. So it's a little bit harder, times C plus W. And when we FOIL or distribute, 1.5 times C, 1.5 times plus W is that, and it's equal to 12. So this is our new equation. Without a denominator, that was the point. We had to get rid of the denominator. On the left, it's a little bit different as well. We have to get rid of this denominator. So we multiply by the entire denominator on both sides. It goes up to the numerator, cancels on the left. And this time we have to FOIL this 3 times this bracket. You'll discover the more you practice these, the easier it gets. The less you practice, the more confusing it is. So you get 3 times C minus 3W. And you have an equation. Only this time it's harder. It's harder to figure out what it is alone. And I don't like working with 1.5, so I'm going to work with 3. I'm going to find an equation for the canoeist speed. So I'm going to add this 3W to both sides and get rid of it on the left side. It's going to cancel on the right, on the left side if I add the 3W. But I don't want 3C is equal to something. So I'm going to divide by 3. But once again, because I have a plus over here, these are married. So when I divide by 3 on this left side, it's going to disappear. And on the right side, it's going to become a whole new annoying fraction. Now, the simple answer is if the 3 can go into both, it must go into both these numbers, you can simplify. Or you can think of it as 2 separate denominators, just as way you make a common denominator. It's really like this. 2 separate denominators. It's clear that 12 divided by 3 is 4. And 3 divided by 3 is 1. And we just don't write ones. So you get a formula for C. C is equal to that. The canoeist speed is 4 plus the W. That means I can rewrite the more complicated thing. And where I see C, I can put in my new formula. I got to FOIL that. 1.5 times 4 is 6. 1.5 times plus W is 1.5W. Plus 1.5W, here's where it gets a little bit easier, is equal to 12. These are both W's, so just look at the number. What's 1.5 plus 1.5? It is 3 W's. I got to get rid of that 6. I'm going to subtract 6 on both sides. And I get 3W is equal to 6. A little bit easier now. I'm going to divide by 3 on both sides to get rid of the 3. It's going to disappear on the left side. And I get the wind speed is equal to 2. 2 kilometers an hour. You're probably going to lose points if you don't put a speed, because they're looking for no speed. And once you know the speed of this, it's easy to figure out the canoeist speed, because you can just replace it with the water in the simple equation. C4 plus 2 kilometers an hour, the canoeist speed is 6 kilometers an hour. Okay? They're all like that. So you see 2 hours, 3 hours. Whenever you see 2 different times, this is the way you're going to do it. Now, just to make sure, we're going to go down to the answer key. So, yeah, he's solving one equation, then he's solving the other, then he's figuring it out. And there you go. Yeah, he's doing it. So let's see. S. Downstream, this is the speed. He's making it simpler. This is the other speed. He's adding them. Because when he's using a different technique. It's the same technique. I'm using substitution. He's using elimination. So it's the same technique. If he can't really give you bad marks for doing a different technique, I'll show you what his technique is. But he simplified both equations to do it. It doesn't work otherwise. When he says add, so he has this equation. Sorry, C plus this is equal to 8. And he has this, which isn't easy for you to see because we had 1.5s. But when he has it like this, you're allowed to add. This is called, what it's called. You're allowed to add this equation to this equation to this equation. C plus C is 2C. Plus S plus minus S, which becomes plus S minus S, goes away. And 8 plus 4 is 12. We divide by 2. Canoeist speed is 6. Instead of substitution, I think it's called elimination. But this only works when you have an opposite sign. You can add them. You can also subtract them. So C minus C is 0. S minus minus S is 2S. 8 minus 4 is 4. Divide by 2, S is equal to 2. I use substitution. I find substitution easier. You do whatever you're comfortable with. But you can see from his answer key over and over again, that's what he's doing. Okay? For the first 5 questions, I think. First 5 questions. So let's just come up with formulas now for the other ones. There we go. Eternally frustrating not to copy the screen. Motorboat, it's the same thing. We just got to figure out the velocity with the stream. We know right away. Motorboat speed with the stream, we're going to call it motorboats plus the water. And we're going to call it motorboat minus the water. Since we have time is equal to velocity over distance, we're going to rewrite that twice. One for upstream, one for downstream. Same way as we did all of the first 2. Twice, 2 equations. Okay, well, our time one way. The shorter time always goes with the plus. So the shorter time always goes with the win because it takes less time with the win. And the longer time always goes with the minus. Oh, was it velocity? No, sorry, it's distance over velocity right there. I screwed that up. See? Right. Fortunately, our distance in these questions is always the same. Which is why if you'd rephrased it in terms of distance, you'd actually have an easier time. But whatever. That's what I did when I first solved them. With the wind's got to go with the shorter time. Against the wind's got to go with the longer time. And we do the same thing. So you don't like working with the word hours. So we're just going to work with the number 2, the number 3, and the number 48. Okay, so we got to multiply the m plus w because it's like, so I'm not going to go through how, I've already explained why. So when I multiply, the whole denominator disappears on the right, and on the left it becomes this is equal to 48. When I distribute it, 2m plus 2w is equal to 48. Okay. I just want the man speed, let's say. So I'm going to say it's 48 minus 2w. I'm going to divide by 2 to get rid of it on the right. And it's essentially like dividing both these things by 2. There's another way of thinking of it. So it's equal to 24 minus w. These are like fraction methods. You should have known about fraction methods before. This one, of course, is slightly different because I've got to multiply by m minus 3 on both sides. It's only slightly different. On the right side, of course, it disappears. When I distribute, I get 3m minus 3w. I'll show you what your teacher does. So he isolates the m again. He divides by 3. 48 divided by 3 is 16. 32 cannot be divided, plus it's 3w. And 3w divided by 3 becomes w. So you see, he does it like this. And he actually keeps the equations, plus w. Keeps the equations like that, and he puts the w on the same side. So what he does is right up this stage here. He divides everything by 3. So you're allowed to do anything you want to any equation, as long as you do it by the right. These will cancel out, and this will become 16. So he gets this. And he keeps it on the same side. I think it's more confusing. And then over here, he divides everything by 2 first. Get rid of that. And when you divide everything on the right by 2, you get that, and you get this. So when he has his equation like this, because the w's, he can either add them or subtract them, and he adds them. So m plus m is 2m. Minus w plus w is minus w plus w, which is 0, so I get 2m. When I add these, I get 40. 2m is equal to 40. Divide by 2, m is equal to 20. So he's doing it like this, and then you go back here and you say, okay, whichever equation you want. This one, demand speed is 24. This is the wind speed, rather. No, 2m is equal to that. That's the man speed. So over here, you do 20 minus 24 minus w is equal to minus 4. So divide by minus 1, wind is equal to 4. Or you can put it in this one. 20 minus the wind is equal to 16. Actually, this one's easier to do. 20 plus wind is equal to 24. Subtract 20 on both sides. Wind is equal to 4. So that's his technique. I personally think it's easier to use substitution. So I got this for m. So that means I can substitute into this one. 3, 20. You're allowed to use whatever technique you work. They're all techniques that work. There's like different options in math you can go about, but so long as you apply the method the same way each time, you're fine. Okay, 3 times 24 is 72, minus 3w, minus 3w is equal to 48. Minus 3w is the same thing, minus 6w, not 0. You subtract 72 from both sides. 48 minus 7, 50, 22, 24, minus 24. You divide by minus 6 on both sides. Wind speed is equal to 4. Then you take that, you put it in your simplest equation right here. And I think we had m. We had m is equal to 24 minus wind, so minus 4. M is equal to 20. Should get the same answer no matter what. Okay. Cyclist has 2 different times, so it's the same method. Let's just make sure he's using the same method over and over again. Yes, yes. He's adding, he's using elimination each time. Yes, it's the same thing right until we come to 6. So for a cyclist, oh, that's the answer key. Cyclist. So again, we've got to use our formula of time is equal to distance over velocity. And we've got to use it twice, upstream and downstream. And we know that this case, the cyclist against the wind is going to be C plus, or with the wind is C plus W and C minus W. C minus W will always take the longest time. So we can see his time is 1.5 hours against the wind and 1 hour with. Going to make our life a little easier. So our time with the wind is 1. And against the wind is 1.5. And we know our distance is always going to be the same, 30. 30. And the shorter time gets C plus W. And again, treat it like a bracket. And the longer time will always get C minus W, it's the speed. And again, treat it like a bracket. Then you solve individually, and I don't know what technique you want to use. So multiply both sides by CW on the side. So you get, it's 1 is equal to 30 divided by CW, by the way. C plus W. So when I multiply both sides, the 1 multiplies C plus W on the left side. And it's equal to 30. And when I multiply by the brackets on the right side, I get 1.5 times C minus W is equal to 30. And when I distribute, it comes this. Now, I could divide everything by 1.5 and get them individual so that you can only add or subtract when you have 1 and 1 and 1 and 1. So I'd have to divide this by 1.5 and other use the subtraction method. I don't know what method you want to use, but here's our 2 equations. substitute or add, you'll come up with the answer. Okay. Number 5, again, same thing. 2 different times, so we're going to use this method. And you have to do 2 separate equations, because when you do it, when you add this is why you have to learn the 2 techniques. So he's going with the tailwind, so we've got airplane with wind and airplane against the wind. That's our 2 different speeds. It's always time is equal to distance. And so the shorter time is airplane plus wind. And then his longer time was 2 hours is equal to the distance, 600, over against the longer time is against the wind, like that. So that's our 2 fractions. We want to get the fraction gone, so we multiply both sides by the, we want to get the denominator gone. Good enough. So essentially it's like that. When you get fast enough, you just kind of realize, oh, it's like a slide up. We'll do your teacher's method this time. 1.5 times A plus 1.5 times W is equal to 600. We're going to divide everything by 1.5. When things are added, you have to divide them individually. They disappear here on the left. On my mouse key. And we discover 600 divided by 1.5 should be of what, 400? No. 400? I think it's 400. Yeah, 400. So that's that equation. On this equation, if you want to make your life simpler, before you distribute, just divide by 2. It'll cancel. That's what I should have done, actually. And this becomes 300. Instead of distributing, you can just divide that number out. Get it? That's what your teacher's doing. He's getting into individual single columns. Now you can add and subtract, and either will work. You can add and subtract, or subtract, and neither will work. Let's look at what happens when we add. So essentially adding everything in common. A plus A, 2A. A plus minus W is W minus W is 0. 400 plus 300, 700, divide by 2. The airspeed is 350. Go back to my easier equation. Subtract W here, 400. Sorry, subtract airplane speed. The wind speed is 50. Okay. Please note you can also subtract them. A minus A is 0. W minus minus W is 2W. 400 minus 300 is 100. Divide by 2. Wind speed is 50. Substitute back here, 50. Subtract it. Airspeed is 350. Both work, plus or minus. Substitution also works. Doesn't matter which one you do. So substitution would be A is equal to 400 minus 400, and you stick it in when you see A here. 400 minus W is minus 2W equal to 300. Subtract 400 from both sides. Minus 2W is equal to minus 100. Divide by minus 2. Wind is equal to 50. Put it back into your equation here. 400 minus 50 is airspeed 350. 6 is where we get into something different, because suddenly they're talking about a total time, which means you have to add 2 separate equations, which makes it hard. Okay, so now that we get into this, Oops, sorry, I had to pause there and answer. Okay, so just really quickly, it's going to be the same thing as the first ones. Keep these two. And I'm just going to give you the equations. So again, we're just going to call it a boat instead of a tugboat. So we got tugboat plus the water and tugboat against the water. We again have a time. It's always going to be the same formula. Time is equal to the distance divided by velocity. We're going to need the equation twice. We're going to have to solve two individual equations because they give us two different times. Okay. Remember that the time, the shorter time, will always go with the m plus w. So 4. And the other time is 5, right? 5. The distance will always stay the same in these, 80. And the velocities, the shorter time gets the b plus the w, and the longer time gets the b minus the w. Then it's the same thing. We have to multiply both sides by this. And again, it really helps if you put it to bracket because it'll remind you to distribute. So this one just slides up here. And this one slides up here. Really, that's what's going on. Then we're going to expand. 4b plus 4w equal to 80. Your teacher's dividing everything by 4 to get it into a simple equation, which works well if this number is divisible by 4. This won't work well. My substitution method works better when you have numbers that aren't divisible easily into whole numbers. Then it's my substitution method. So he should be teaching you both. So I'm going to stick with my substitution, but just know that you would divide everything by 4, and this is the alternate equation. And then when we expand this one, he's picking numbers that are divisible by 4 and 5. And I distribute. I get 5b minus 5w is equal to 80. And then he's dividing everything by 5. So I'll give you the alternate version. B minus w is equal to 16. So these are the equations he's doing. It only works because this number is divisible by 5 and 4. If it doesn't work, it's smarter to use my substitution. Very quickly, here's my substitution. I'm going to get rid of all this other stuff we don't need anymore so that I can show you both methods. Let's go to his method. He's just either adding or subtracting. Adding or subtracting works because this is a negative and this is a positive. If they were both positive, you'd have to subtract, but it doesn't matter. We're going to just add because that's what is easier to do. B plus B is 2b. One of these should always disappear. Minus w plus w is nothing. So when I add this, 36. Divide by 2, 36. 36. There we go. Divide by 2, b is 18. Put it back into this equation. Wind is 2. So the tugboat speed, remember where speed is 18. Speed is always a distance per hour. And the wind speed is, or the water speed rather, is 2 kilometers per hour. Going back to my method, maybe his method definitely works better here. But we're going to get b all alone. We're going to divide by 4. And then we substitute it into this one wherever we see b. So I see 5 times b here, but b is equal, sorry, it should have been minus, should be minus 4w, 4b minus 4w minus w. There we go. So b is equal to this, so 5, and remember to put it in brackets. 5 times 20 is 100. Minus 5w is minus 5w is equal to 80. Equal to 80. Minus 5w minus 5w minus 10w. We subtract 100. You get minus 20. You divide by minus 10 on both sides. Wind is equal to positive 2. Then you go back to your easy equation on the left. B is equal to 20 minus W. W is 2. B is equal to same answer. Substitution will work really well when the numbers don't divide easily. Okay, so they're all the same. So the last two, 9 and I'm just going to give you the equations. There we go. Oh yeah, we didn't do jet. Okay, I'm just going to do the 3 equations for them. So again, it's always jet plus wind and jet against the wind. It's always the time 1, which is 2, is equal to the distance, which is constant. And the shorter time, which is 2, is always divided by this speed. And the 3 is the same distance, but divided by the minus speed because it's a slower time because we're going against the wind. There's your 2 equations, solved in the same way. Did I just do 5? I think I just did do 5. I don't know what happened to my 10 there. I did 10 do that. Is that what the question looks like? No. Okay, there we go. Okay, what's the equation for the tug? It's the shorter time is equal to the distance divided by the boat plus the water. And the longer time is equal to the distance divided by the B minus W. Same method, get rid of the denominator. So it's like that. That's my 2 different equations. Multiplied by B plus W, multiplied by B minus 1. Distribute, sort, whatever. And 10 is the same. So for some reason, only 6 was different. Okay, city A to B. This might be different. So it's 1,500 kilometers, 2 with the jet stream, returns in 3 hours against the... No, it's the same. So we got 1 speed. The time, the shorter time is the distance with the plane with the wind, also known as the jet stream. The longer time is the same distance divided by the plane minus W. Get rid of the denominators. Instead of distributing, just divide by 2. This one, we get rid of the denominator by multiplying by P minus W. We go to 1,500. Instead of distributing, just divide by 3. And we have our 2 equations. You can either substitute, and actually that is easier. You can actually substitute or add. So when we add, we get 2W is equal to 1250, or the plane speed is equal to 625. And we go back up to this one, and so we discover that the wind is 125 kilometers an hour. I think that's it. Let's see if that was it. Yeah. And remember, kilometers per hour, kilometers per hour. That's all of them.